Hey guys, welcome to lesson 0.2. Today we're going to talk about how can I solve equations involving inequalities and absolute value. Really quick review. There are four symbols that we use to represent inequalities. What are they? So, many of you remember less than, greater than, less than or equal to, and greater than or equal to. However, reading these inequalities are a little bit tricky. One thing that we need to remember is always read the inequality from the variable. What do I mean? Let's look at these examples. Write the following in words. The first one is x. I'm starting with my variable less than or equal to 21. So all I'm going to do is x is less than or equal to 21. Start with your variable. Number 2, I'm going to start here. D is greater than 3. D is greater than 3. And number 3 again, start with your variable. Y is less than 1. So the tip is always start wherever your variable is. So I started from here, back, oopsie, I started from here and I went back and my x was in the front, so I just went forward. So identify where your variable, yesterday we talked about a variable. All a variable is a letter that represents an unknown. How do we graph these? Whenever we have less than or greater than, we use an open circle, which looks like this. However, when there's a little line at the bottom that means equal to, we use a closed circle. So let's see how this looks on a number line. X is greater than negative 3. I am at negative 3 with an open circle. Anything greater than negative 3 goes to your right. Number 2, start with your variable. X is greater than or equal to negative 1. So that will be a closed circle because it has the line at the bottom. Greater than goes to the right. When I combine two of these, this is what is known as a compound inequality. All that means is two inequalities combined. So we're going to break these up. We have two inequalities now. So 1, 2. Let's graph it. First one, x is greater than or equal to negative 4. Greater than equals a closed circle all this way. X is less than or equal to positive 2. Again, closed circle, and it's going to go this way. So your answer is basically everything that's in the middle of these. So anything that's between these in yellow, that's your answer key. If we look at number 4, x is less than negative 1. So I have negative 1, open circle. Less than means I go to the left. X is greater than or equal to positive 1. Greater than or equal to, it's a closed circle. Anything greater, we know goes to the right. So the thing is that with compound inequalities, it's just combining two, and then you graph what satisfy those equations. How about solving these? The key thing that you need to remember when solving inequalities is when dividing by a negative number, you have to flip the inequality sign. So fill in your blanks and let's do two examples. The first one, say 2 over 3x minus 7 is greater than 23. So the first thing, I want to get rid of my constant. Yesterday some of us learned the constant is just a number by itself. I want to combine my like terms. This is cancel. 2 over 3x is greater than 30. Now I have a fraction. I need to get rid of my denominator. So times it by 3 times by 3. My 3's are cancel. And I'm end up with 2x is greater than 90. Simple one-step equation. Divide by 2 on both sides. 2's are out. x is greater than 45. Always box your answers off. Let's see the second question. 6 minus 4x is less than or equal to 10. So, grouping my like terms, minus 6 on both sides. 6 are out. Minus 4x is less than or equal to 4. Again, we have a simple one-step equation. Divide by negative 4. Divide by negative 4. Cancels. X is, notice, oops, I divide by a negative number, refer back to here. When divided by a negative number, flip the inequality. So here I have less than or equal to. I will flip it to be greater than or equal to. This is a very simple mistake that a lot of students make on the region. So we have to be extra careful. When we divide by a negative number, we have to flip the inequalities sign. Moving on, we have absolute value. The absolute value are just these little lines here. The absolute value of negative 3 is positive 3. The absolute value of a number is the distance the number is from 0 on the number line. So let's look at these examples. Solve for the absolute value of x is 3. What number can I plug in here so I will get a positive 3? Now, x can be equal to negative 3 or x can be equal to a positive 3. Actually, in math, we don't even need to write positive 3. We already know what that is. So it means I have a number line. This is 0, 1, negative 2. This is a negative 3, 1, 2, and this is a positive 3. The number between, and let's get a different color, between here to 0, I go 1, 2, 3. So the distance is 3. Same goes. The distance from here to here is 3. Distance can never be negative. Number 2, solve the absolute value of, solve the absolute value of x if it's equal to negative 3. Now, this is what we need to remember. There is no solution. The absolute value of any given expression is always a positive number, which brings us down to our little notes here. Absolute values can never be a negative number. This final answer will always be positive. Let's see. So, solving an absolute value equation. In this case, A, B, C are constant, which we talked about. Constant are just numbers, where C, is greater than 0. So if we had a situation like this, if ax plus b equals c and I want to find x, there will always be two answers. So the two situations are ax plus b can equal to c, or ax plus b can give us negative c. It doesn't matter. Remember, there's no absolute value now. But whatever I find as x, and if I put it in that absolute value sign, it will give me a positive c. Just like here, the absolute value of negative 3 becomes a positive 3. So if I get a value here for x and it gives me negative c, once I put the absolute value sign, it will give me my final answer, which is a positive c. Let's see how this works in some example. Example 1, 2x minus 1, the absolute value of that is equal to 17. I know I have two scenarios where 2x minus 1 is equal to 17, or 2x minus 1 is equal to negative 17. So the way this works is a simple two-step equation, like my river down here. The ones cancel. 2x is equal to 17 plus 1 is 18. Divide by 2. 2's are out. X is equal to 9. This is one answer. Let's see what happens on this side. Bring my river down. Same goes. Add 1 on both sides. This is cancel. 2x is equal to negative 16 plus 1. Oh, I give you the answer. Negative 17 plus 1 is equal to negative 16 divided by 2. 2's are out. X is equal to a negative 8. How is this even possible? Well, let's see. Let's check our answer. X is 9, so the absolute value of 2 times 9 minus 1. What is this really equal to? 2 times 9 is 18. 18 take away 1 is 17, which is what we're looking for. Check. Then we have negative 8. So absolute value of 2 times negative 8 minus 1. What is this really? Is this really 17? Let's see. Absolute value 2 times 8, 2 times negative 8 actually is negative 16. Negative 16 take away 1, and I'm just going to continue along here. Negative 16 take away 1 is actually negative 17, and the absolute value of negative 17, as we all know, is, let me just write this a little better so you can understand. The absolute value of negative 17 is positive 17, which is exactly what I want. Check. Let's look at one more example because I know that was a lot to take in. Again, the first thing we know, we have two situations. 11 over 4x is equal to 7 over 12, or 11 over 4x is equal to negative 77 over 12. The first thing and the easiest way to go is, I know that 4 and 12 are multiple of each other, so I'm going to make these as same denominator. How would I get from 4 to 12? Perfect. Times it by 3. Whatever I do at the top, bottom, I need to do at the top. 3 times 11 is 33. So now that I'm working with this, I can times it by 12 so I can get rid of the denominator. These are cancel. These are out. 3x is equal to 77. Now guys, we just have a simple one-step equation where I divide it by my coefficient, which in this case is 33. This is cancel. X is equal to 77 over 33. If I want to be furthermore, I can divide this by 11 and I will get 7 over 3. Just read the problem. Did it ask you to simplify? So if it does, simplify, then your final answer would be 7 over 3. If it didn't ask you to simplify and you leave your answer as 77 over 33, that's perfectly fine. Let's see. But there's a second scenario. What if it was negative 77 over 12? So again, I'm going to keep it the same way. Make it the same common denominator. It's always the easiest thing to do. Whoops. 77. Again, times this by 3, times this by 3. This becomes 33. I'm going to multiply by 12 on both sides. This is cancel. This is cancel. 33x is equal to negative 77. Again, simple one-step equation. Divide by my coefficient. This is cancel. X is equal to negative 77 over 33. Or simplified version, negative 7 over 3. Whichever the problem asks you for. Remember, you're not sure about something, just rewind the video, pause it, go back to it. Once we're all set and copy our notes, let's move on to Portfolio 0.2. You have about 30 minutes to complete this handout. Remember, keep your portfolio binder in order. We will be doing monthly unit checks. After every unit, you will be getting a binder grade. So, thank you for listening.